Hello friends, welcome to e-learning session on PLC ladder logic. In this video, we are going to see various techniques of PLC programming. What is ladder diagram programming? Advantages of ladder diagram, different brands of PLCs and their addressing. We will also see rules for constructing ladder diagram programming. Different techniques of PLC programming are ladder diagrams, instruction list, sequential function charts, structured text and function block diagrams. Ladder diagram is graphical language representing logical relationship between input and output. What are different advantages of ladder diagram programming? Ladder diagram programming is a simple logic construction and more reliable than an electronic circuit controller. It is easy to learn and read the program which is written in ladder diagram program. Every programming symbol performs specific actions. Ladder diagram having good representation for discrete logic. It is easy to troubleshoot ladder diagram program. Shut down the power without the switch. So these are the advantages of ladder diagram programming. So in this video, we will just see how programming has been done using ladder diagrams. Let us see different brands of PLC and their addressing. So let us start with ABB PLC. The format for digital I/O address is for input address it is I0, I1, I2 and so on IN. For output address, the addressing is Q0, Q1, Q2, Q3 and so on. For Siemens PLC, the structure is file type byte number dot bit number. So address for input is I0.0, I0.1 and so on. If it is 1 byte address, the last addressing will be I0.7. Similarly, for output, it is Q0.0, Q0.1 and so on. For 1 byte output addressing, that is Q0.7. Let us see for Allen Bradley PLC. It is slot number, file type, colon, slot number, dot, word number, / bit number. So for 1 byte I/O address, for input address I:0.0/0 and the last address if it is 1 byte I:0.0/7. Similarly for output it is O:0.0/0 up to O:0.0/7. Then for Delta and Mitsubishi PLC, the input address is given as X0, X1 and so on up to Xn. Whereas for output, it is to be written as Y0, Y1, Y2, Y3 and so on. Let us see how ladder diagram programming is constructed for simple circuit. So figure shows a circuit and ladder diagram for switching on or off an electric motor. Figure A shows circuit and figure B is known as ladder diagram in which the power supply is always shown as two vertical lines with the rest of the circuit as horizontal lines. The power rails is also known as rails are like the vertical sides of ladder with the horizontal circuit lines like the rungs of the ladder. Hence, it is termed as ladder diagram. The horizontal rungs show only control portion of the circuit. Now, in drawing ladder diagram, we have to follow certain conventions. Those conventions are: first, the vertical lines of the diagram represent the power rails between which circuits are connected. The power flow is taken to be from left hand vertical across rung. So power flow is from left power to right. Each rung on the ladder defines one operation in the control process. The ladder diagram is read from left to right and from top to bottom. Each rung must start with an input or inputs and must end with at least one output. Electrical devices are shown in their normal condition. Thus, a switch which is normally open until some object closes it, it is shown as open on the ladder diagram. It is also known as examined if closed, that is XIC. A switch that is normally closed is shown closed, that is examined if open, XIO. Next rule is a particular device can appear in more than one rung of a ladder. The inputs and the outputs are all identified by their addresses, the notation used depending on the PLC manufacturers. This is the address of the input or output in the memory of the PLC. Now, next rule is inputs can be used in series as well as parallel to form a connection. So now this ladder diagram shows the number of inputs I1, I2, I3. Those are connected in series, and I1, I2, I3, I4 connected in parallel and can link with different outputs Q1, Q2 respectively. Next rule is outputs can be used only in parallel. Outputs here as shown in this ladder diagram. Outputs, those are Q1, Q2, Q3, Q4 are connected in parallel along with single input I1. If the single input I1 is normally closed contact, then outputs Q1, Q2, Q3, Q4 will be activated or on. And in this ladder diagram, the I1 is normally open at that time. All outputs Q1, Q2, Q3, Q4 are not activated. Next rule is one input can be used in multiple times in one program. So as shown in this ladder diagram programming, the input I1 which has been connected in rung 1, rung 2, rung 3 and the corresponding outputs are Q1, Q2, Q3. So as per the third rule, a single input can be used repeatedly in different rungs. So this single input I1 has been used thrice in this particular programming. Next rule is one output cannot be used multiple times in one program except in set reset and latch instructions or functions. In the function set reset, the same output address is used and it can be connected to the same or different inputs. So like in this ladder diagram, Q1 which is connected in parallel with normally open contact I1. Next rule is input address cannot be used as output address. And input, that means input address used only for input. The same input address can be used as multiple inputs and it cannot be used as output. And the last rule one has to follow while drawing ladder diagram programming is outputs address can be used as inputs address. The last rule is for cycling process, that is process continuous from start to end. In this image below or programming below, the output coil works as the input coil with the use of latch unlatch function. So output address use as input address. Thank you.